In this reading, we will see how a line and the curve intersect with each other, and resultantly the roots that we are going to get after the intersection. We'll have a look over here. As you could see in the first figure, this curve is intersecting this line at 2 points. So it is going to give us two real roots over here. So we know the condition for an equation to giving a real root, its discriminant should be greater than 0. So we should write here like it will provide us two distinct real roots. Now in the next figure, the curve is just meeting with this line, or this line is tangent or the curve. So we know that this is the condition for equal roots. So we are going to have the discriminant should be equals to 0. Two equal real roots. And line is tangent to the curve. Whenever you meet up with such condition, you have to keep that discriminant equals to 0. And you are supposed to think of like getting two equal real roots after it. Now in the third one, we have a curve is not even intersecting or not even meeting the line. So that's why we have discriminant less than 0. So this is the condition for no real roots, because there is no common point in between these two lines in the curve. Now let's solve some past paper question to further solidify the concept. Right, so in this question, determine the set of values of the constant k for which the line y equals to 4x plus k does not intersect the curve. Does not intersect the curve. It means that its discriminant should be less than 0. So let's start solving it. We have y equals to 4x plus k. We'll just substitute this value of y into the curve equation. So we get x square is equals to 4x plus k. Rearranging the equation, minus 4x minus k is equals to 0. We know the formula for the discriminant is b square minus 4ac, and we need to equate this thing should be less than 0 because there is no intersection in between the line and the curve. So from this equation, a is equals to 1, b is equals to minus 4, and c is equals to minus k. So minus 4 whole square minus 4 a, and c is minus k. So 16 plus 4k should be less than 0, and k is less than minus 4. The question is, find the value of constant c for which the line y equals to 2x plus c is a tangent to the curve. That is the most important thing for this question. By this condition, we know that we should need to equate this discriminant should be equals to 0. So now just substituting the value of line into the curve equation, and we get after substituting the value of line into the curve, just simplify this equation, and this equation simplifies to 4x square plus 4c minus 4 into x plus c square is equals to 0. As we know that this line is tangent to the curve, so we need to apply the discriminant condition and put it equals to 0. So for this equation we have a is equals to 4, b is equals to 4c minus 4, and c is equals to c square. So substituting back to the discriminant equation, we have 4c minus 4 whole square. Write a formula here, b square minus 4ac is equals to 0. So b square minus 4, a is 4, and c is c square is equals to 0. Opening this identity and solving it, we get so 16c square minus 32c plus 16 minus 16c square is equals to 0. Then minus 32c is equals to minus 16. Then c is equals to 1 upon 2. So this is the value of constant c. We need to substitute this value of c half in it so that we could get these two equations tangent on each other.